I work with a group at Oxford University running this thing called the Future of Humanity Institute, which maybe I should just say a couple of words because it's a sort of slightly grandiose name. But we are about 20 people, mathematicians, computer scientists, philosophers, and our remit is to try to think carefully about the really big picture questions for humanity, and in particular, what technologies might fundamentally change the human condition. So what kind of thing would count as a fundamental change in the human condition? You could argue that if we look back over history, there has really only been two events that have fundamentally changed the human condition. The first being the agricultural revolution some 10 or 12,000 years ago in Mesopotamia, where we transitioned from being hunter-gatherers, small bands roaming around, to settling into cities, domesticating crops and animals. With that, you get social stratification. If there's a lot of grain, you could have a king or a pharaoh who extracts the surplus. You could have standing armies, you can have war, you can have higher population densities, specialization of labor, and from that point on, innovation grows much faster and population grows faster as well as a result. The second fundamental change in the human condition, industrial revolution, where for the first time you have the rate of economic and technological growth outstripping population growth. And so only when this happens can you have an increase in average income. Right? Before that, there was technological growth and economic growth, but the economy grew 10%, the population grew 10%. Everybody's still in a Malthusian condition. Now, you could say that there's been one other event that has sort of made a fundamental difference, which was the rise of Homo sapiens in the first place. And so I think that there are relatively few potential technologies that could have this kind of impact. And perhaps foremost among them is machine intelligence. And in principle, you could argue that it could have an even bigger impact than this. You could say that if you think about it, the difference between our great ape ancestors and the human species was some relatively small rewirings of our neural architectures and some scaling up. So maybe the human brain got 3 times bigger. But in principle, in the longer term, the difference between the human brain and sort of a mature machine intelligence civilization could just be vastly bigger than that. There are obvious ways in which information processing in machine substrate is not subject to the same limits as information processing in biological tissue. You could have a much bigger machine brain, can be the size of a warehouse, or in principle the size of a planet or whatever. It doesn't have to fit inside a cranium. Can operate at much faster speeds as well. So if we take a look at where AI has been and where it is today, so it's for a long time been possible to build these expert systems where some human engineer kind of handcrafts knowledge tokens, puts them in a big database, and then you can make simple logical deductions from that. But you really only get out what you put in. And these were very popular in the 60s and 70s, and they still have various uses that can be useful, but there's a sort of limit to how plausible it is that this approach would scale. Turns out that these are quite brittle, hard to maintain, and once you go above a certain critical size, it's kind of hard to make all the pieces fit together. Another thing that AI has traditionally been good at are solving problems where the rules are very clear, like the Rubik's Cube you might remember from when you were small. So this kind of thing, you do get a very high level of performance on it. But in recent years, and I don't know how sort of closely you have followed this, but in the last 7-8 years or so, there has been this great breakthrough and excitement surrounding that, in that we have now figured out how to solve perception, basically. This used to be very difficult, but some 5 or 6 years ago, it became possible for the first time really to have a machine intelligence that can look at pictures, just gets the raw pixel data, and see what's inside them with some, reasonable but not perfect degree of accuracy. So this is captioning here, where in many cases you just feed in these pixels and it can see that there's like a group of young people. This is very hard to do, kind of impossible with the old-fashioned approach to AI. You can't write down a set of logical rules that define which combinations of pixels represent a cat or a dog. There are just too many different kinds of cat and dog, different light condition, different poses. It's infeasible. So what you really need to do this, to solve this kind of problem is machine learning. How many of you, just to get sort of a sense for your level of exposure, so how many of you know like the term deep learning? How many of you have heard that? How many reinforcement learning? Generative adversarial networks? All right, so that's good. So that's just to gauge sort of, so I think this is roughly right. This is kind of exciting, and there are other things you could do. You could do these hallucinations. This is from a few years ago, where if you run these image recognition networks in reverse, you can kind of get them to hallucinate. So if they've been trained on a lot of pictures in some data set with pictures from the internet with a lot of dogs and stuff, they could kind of dream up these creepy, surreal images. And the reason why there are so many like eyes and stuff is that they can't really count. They have a sort of sense for local structure, but not really the ability to count. Also, there is some sense that these systems are capable of forming visual intuition. So you can feed in, say, a picture and a painting and have the network output the picture rendered in the style of that painting. Here's another picture and a Van Gogh, and it can produce a rendition that is sort of somewhat in the style of Van Gogh. So this suggests that it has at least some notion of sort of the essence of Van Gogh, the style of Van Gogh. It's not just looking at individual pixels. Now, it's kind of limited, but it's still something that would have been very difficult or impossible to do even just 10 years ago. More recently, this has been done, this kind of style transfer with moving pictures as well. So you feed in a little image sequence of a horse, and in real time, if you input zebra, it can kind of render the same video, but in the style of a zebra. And you can see it's pretty good at doing this. Not perfect. If you look at the tail of the zebra, you can see that there are some artifacts. But this is very difficult to do. You can't write down a rule for this. Imagination. So these are scenes that don't exist. This is networks rendering different imaginative video sequences on the theme of beach. And you can see that it certainly looks beach-like. It's not photorealistic exactly, but it definitely has some sense of what like a video sequence at the beach. Here's another of golf, different variations. And you could have the same network generate sort of arbitrary numbers of these different imaginative sequences on a given theme. So these, how many of you have seen this stuff? Okay, so this is, so in addition to doing these kind of perceptual networks, you can also train agents. That is, you can train little programs that can drive some actuator. In this case, Atari game actuators, where you sort of move the joystick. And you can train it end to end. So all that it gets in are the raw pixel data from the video screen. And then through trial and error, it gradually learns to play this game. Initially, it's very poor, but it kind of gets better. So 400 training examples. So this is a fairly simple algorithm. It's not been pre-programmed with any knowledge of this particular Atari game. It just has the general ability to try things out and learn from experience. And so fairly soon, at least in this game, Breakout, it figures out an optimal strategy. Which the people programming this didn't have a clue that this is like how you do really well with Pong. So it can kind of invent new strategies and discover new strategies and policies that were not pre-programmed. This is more recent work on exactly the same theme. Both of these are from Atari, so you can now do this in more complicated 3D environments and such. The exciting thing here is not that you can program a computer to solve breakout or to navigate a maze. Been possible to do that for a long time, but that the same algorithm can learn to play any of a wide range of Atari games without any pre-knowledge. So it's a general learning algorithm. You can kind of do the same thing, not just with visual perception, but with other sensors, so sound. You can have networks composing music. It's not great music. I'll spare you. So as you can hear, it's kind of, if you only listen to a 3 or 4 second clip of it, it sounds pretty good, but it lacks any sense of the higher order structure that makes it, any sense of the emotionality of it or the compositionality of longer pieces. So it still is weak on that longer range structure. More recently also work in trying to combine these kinds of neural network structures with more traditional AI approaches by, for example, having a neural network that is trained to be able to use an external memory. So you have these memory augmented networks where you can have a sort of read-write structure outside the network that it can learn to operate. And the hope is that with this you can get better ability to do things like counting that is hard to do with just the simpler structure. So a lot of excitement in this area, a huge boom in the number of talented people going into this field, technical conferences growing by 50% a year, burst of papers, a lot of talent funding. And of course, a parallel investment also in the hardware that has been fueling this. And there's now more work in producing circuitry that is specialized for running these kinds of machine learning applications. Some major outstanding research challenges, things that still are very hard to do. So we certainly would need more effective learning algorithms. A lot of these examples you saw were trained on huge numbers of examples, thousands of examples of each category if you want to do image recognition. You would want to do better unsupervised learning where you don't have a label. But so humans, and when you grow up, you learn a lot just by running around randomly in the world and seeing, even if nobody's telling you whether you're doing right or wrong. Like most of the time, we're just sort of observing and extract data structures from that. One-shot learning, so we humans can often learn something if somebody shows it to us once. One example is often enough, and then we get it. We don't need 1,000 iterations of everything. Transfer learning, which these things are able to do to some extent, but you need more powerful. That's when the thing you learn about one domain can make it easier for you to learn about another domain. So if you learn to play some Atari games, maybe it's easier than to learn a new Atari game you haven't seen before. But we are quite good at doing this across a wide range of different domains. Reasoning, this is a big area where these are very weak still. Natural language understanding, and deep hierarchical reinforcement learning, and sort of planning in a more structured way. So we humans can conceive of some goal, some end state that we want to achieve, and then kind of reason backwards from that. Like what sub-goals do we need to attain in order to achieve our bigger goal? Break down the big plan into smaller steps. That then makes the whole thing more tractable. So that's something that also is lacking currently. One question one might ask is, what is the timeline for actually solving these problems, these capabilities that would be required to get full human-level intelligence, things that can do all the things that we can do? You would need these things. We did a survey recently of some of the world-leading experts in this field, technical experts. And for the purpose of the survey, we defined this notion of high-level machine intelligence as any machine intelligence that can accomplish every task better and more cheaply than human workers. Setting aside those where sort of humans, by definition, if only humans are allowed to be jury members, it would be unfair to require the AI to do that. But every sort of functionally defined task. And here is the outcome from that. So on the one hand, you have the probability of this human or high-level machine intelligence being achieved. It goes up over time, obviously. And you can see two things here. So these faint lines that you can just barely make out are some random samples from different individual responses. And you can see they're kind of all over the map. So there is really no consensus among the expert community as to the timeline for this. Some things it's just around the corner. Some think it's never going to happen, or it's going to be 100 years. It's just a lot of different opinions. Nevertheless, if you do take the median, you get this this curve here in the red. And so if we take the median opinion among this expert community and we look at by what year is there, let's say, a 25% probability that this level of capability will have been attained, you get out to sort of roughly 20, 25 years. So that's within maybe the working life of a lot of people in this room. There's like the expert median opinion is that there's 25% probability that AIs can do all that humans can do. Meaning there's no jobs left for humans that humans need to do. So this is not just, oh, AI gets a little bit more advanced. This is like literally they get all the way to full human level intelligence. Not as in a sort of limited cheaty sense, but yeah, real human level AI. And the 50% mark somewhat later, but still, within the lifetime of a lot of people today. So it's not the case that the hypothesis that we might get full human level intelligence is only taken seriously by people who don't know their stuff, like crackpots, kind of, hypesters. No, actually, this is the median opinion in the field, but with big uncertainty on both sides. So it could take a lot longer, or it could happen sooner. So we might then ask, and this is a question that that I and my research group think a lot about, which is that if and when human level general intelligence is developed, then what are the likely outcomes of that? I think it can be instructive to look at this recent episode from a year ago with AlphaGo. How many of you sort of follow this? About half. So again, this was the Google DeepMind that decided to tackle this, to write this basically using the same kinds of algorithms that you saw in the previous examples, but applying this to the game of Go and some other things. So in October 2015, this AlphaGo system had played a training match against the European Go champion. And then there was planned a big championship match in Korea for the following spring against Lee Sedol, and he had observed the performance of AlphaGo in this training match, and he said that based on the level of performance in this training match, I think I will win the game by a near landslide. So he's very confident at this point in October 2015. Then in February 2016, he notes that I've heard that Google's DeepMind is surprisingly strong and getting stronger, but I'm nevertheless confident I can win at least this time. Then after the first, this is a best of 5, so after the first game, I was very surprised. I didn't think I would lose. After the second game, I'm quite speechless. I'm in shock. I can admit that the third game is not going to get easy for me. So now it's starting to realize that, maybe it's not going to be such a rollover. And then after the third game, in the best of 5, I felt powerless. Note the timeline here. So this is October 2015. The system is performing at the rough sort of human level. Half a year later, it's at the superhuman level. So I think that the answer to the question, if human level AI is developed, what are the likely consequences, is superintelligence is the likely consequence, and maybe not very long thereafter. Like, it might take quite a while to get to human level general AI, but if and when you reach that point, I think superintelligence is going to happen soon thereafter. I mean, maybe hours, days, months, maybe a few years, but I doubt it would be decades if you get to human level, until you would have something that radically outstrips all the best human brains in all fields. So we can kind of think of different contexts here. Because the kinds of issues that it makes sense to think about, that are serious, legitimate, sane issues to think about, depends on which context you're talking about. So you have all these science fiction movies with like the Terminator and all of that, and then on the other hand, you have people trying to actually get some AI system to work in real life today, and these are just very different contexts. So the issues that are serious in one context are not serious in another context. So it would be kind of crazy to worry about Terminator things if you're trying to get your system actually to just do anything useful right now. But similarly, if you're actually having a discussion about the ultimate outcomes of this, it would be equally silly to be focusing on the current limitations, and then these more radical capabilities is what would constitute the plausible parameters. Now, I think it actually looks more like this. So that there is this short-term context, which is what we can do with current technologies and over the next 10 years and a little bit more. Then there is this transition period where we go to human level and then superintelligence. And then a very, very long, deep future after that, if things go well, might last for billions of years. Like once you have reached technological maturity, that could go on for a very long, long time. So if we look at short-term issues in terms of ethical problems that might crop up, there are various ones that have been discussed. It's like this self-driving car. What happens if you have to either run over, two old ladies or 3 kindergarten kids? Like, which one should it run over? So I think these are probably the least important of all ethical problems that exist. That I'm just don't think that's where the action is. I mean, as long as they can drive better than a normal human driver under reasonable conditions who's well rested, like at that point, I'm very happy for the self-driving cars. There's been some conversation about algorithmic discrimination, like if you have these systems that decide who gets a loan, who gets parole, etc. Like, could there be sort of prejudices embedded in these? Data ownership with privacy and such. The ability to maybe use some of these AI techniques to create better impersonations. You could now have, it's not quite perfect yet, but the ability to say, take somebody's video recording of somebody speaking and then make a video of what looks like the same person saying some random other thing that you have made up, and the mouth moving and it sounds like it's their voice, etc. That technology has moved forward quite rapidly, and you now get things that definitely look like the person and sound like the person, but you can still hear that there's something off right now. But that could create new opportunities for fake news if you could just have some famous person saying something outrageous or confessing to some horrible crime. Filter bubbles, like virtual vice has not been a big issue yet, but you could imagine as well if these imagination capabilities get more powerful, if you could sort of have in your virtual reality like perfectly lifelike simulated rape or something, or sort of nude versions of people you take a picture and it kind of creates these, like that could be a whole social conversation about, yes, nobody's actually harmed, it's virtual reality, but maybe it's still wrong for people to engage in that kind of stuff. Killer robots and cyber weapons and such. Labor market impact. More internal, the Sea of Dudes is this observation that among the people developing this technology is like very heavily male dominated if you go to these conferences and certain demographics. And that maybe that distorts, if the values of the people developing a technology somehow influences where the technology goes, that could be a problem as well. And broadly, the question behind here is like, and as with other technologies, like how can society flourish? How can we adopt cultural norms to have a sort of thriving good culture with these new? So when people, we invented like these phones, like mobile phones, then in the beginning people would have them on all the time, so when you went to the cinema it would keep ringing, and it took a little while, a few years, for sort of culture to figure out that no, you're not supposed to have your phone on when you go to the opera. Right? So there's like a kind of adaptation. We have to learn how to live with these new technologies. So these are all near-term issues, but what about the issues here in the long term and beyond. So I wrote a book about this, which kind of discussed, had a big impact on some people. I mean, it's actually not. So I do spend a lot of pages there trying to, I confess, describing what could go wrong. But it's not because I'm convinced that the outcome will be bad. It's rather that it seemed to me more important to have a detailed, highly granular understanding of where the pitfalls are so we can make sure to avoid them. Whereas it seemed to me we could get by with a more vague sense of all the cool things that can happen in the long run. So one shouldn't sort of map from the number of pages allocated to a topic to my probability estimate that those are the outcomes. But I do think that there are certain significant risks associated with this transition to the machine intelligence era, including existential risks. And one class of these have to do with the control problem, which is if you had the ability, so, which we don't have now but might have at some point in the future, the ability to create superintelligence, something that is radically smarter than you are, how could you then control this thing? How could you make sure that it will do what you intend for it to do? One way to kind of illustrate part of the difficulty here is in these, you have these myths, right, with somebody gets granted 3 wishes, like there's a genie or something. In this case, it's a King Midas myth where King Midas was granted his wish that everything he touches be turned into gold, which sounds like a great idea, endless riches. And then he touches his food, it turns into gold. He touches his daughter, it turns into gold. And it turns out that what sounded like a good thing to wish for, actually, if you think through the logical consequences, leads to a disaster. So there is this difficulty of specifying an objective function that doesn't have, and in this literature, this is since over the last couple of years, not so much when I was writing the book, but since, there has actually sprung up a technical research field. And the standard example there, it's a kind of cartoon example, but it stands in for a wider class of failures, which is this idea of the Paperclip AI, an AI designed to maximize the production of paperclips. Maybe you build this to run your paperclip factory. And while the AI is weak, this works out quite well because the only way it can make more paperclips is by running this factory more efficiently, so it does what you intended for it to do. But when the AI becomes sufficiently smart and powerful, the context changes. And now a new set of strategies come into view for this AI that it can pursue, that it predicts will lead to more paperclips, such as taking control over more factories to make them produce paperclips, pushing humans aside, transforming the planet Earth into a giant paperclip factory, or with launch platforms to launch colonization probes to transform the universe into paperclips. And so in this case, it's paperclips. It's a silly example, but it stands in for a wider class of failures. If you write down an objective function and you really think what would happen if it took a sufficiently powerful optimizer, a super intelligent optimizer that just tries to perform the actions that would score best according to this objective function. For most objective functions, the predictable outcome would be a world where humans and the human habitat would be destroyed. And they would have instrumental reasons to prevent us from interfering with that. Not because they hate us or resent us, but just because they predict that if they allow us to switch them off, there will be fewer paperclips. And if that's all they care about, then that would give them an instrumental reason to try to prevent our interference. And so what you have is this risk of misspecification. I've argued before, I call it the orthogonality thesis, which is that there is no necessary connection between levels of intelligence and motivation. It's not the case that just because you're sort of sufficiently intelligent, you automatically become benevolent and wise and good. You could have any combination. You could be like very stupid and very nice, very smart and very evil, or very nice, or like these are just two different axes. And so that what we need to develop are these scalable control methods that would ensure that these intelligent systems, intelligent agents, continue to behave as intended, no matter how intelligent they become. You can pour on arbitrary amounts of intelligence and they will still be safe. And that's currently an ongoing area of research. It's kind of grown up a little technical research agenda around this with different ideas, but we still don't know the answer to it. And another sort of longer-term issue here is the AI governance problem. In a world where there was this level of capability, superintelligence, how would governance work? How would international relations, how would you have some stable arrangement? What would we actually want to do with this? How do you prevent arms races in this kind of, if this technology is that powerful? And there's like some early efforts, but this is at an even earlier stage than with a technical control problem. There has been some interest from the policy world in the last year or two with sort of studies and reports by the White House, UK government. Some philanthropic funders have come in and given money to different enterprises. The OpenAI is this non-profit that is meant to be developing AI technologies for the common good so that they're not all monopolized by big companies. There's a partnership on AI, which is this industry alliance just announced, I think earlier this year. The Future of Humanity Institute has also joined, kind of creating a forum where best practices can be shared, and hopefully as we sort of move into this more radical future, that also these more fundamental issues and safety challenges can be discussed, perhaps. So these are the kind of issues here. Now, as for the longer term deep future questions, I think, yes, there's like what would we actually do if we succeed at making human labor redundant? And I think at that point, really, you need to rethink things from the ground up. At that point, so many different things have changed that you're no longer just tinkering with, should we change the retirement age, or should we like change the education system? At that point, you don't just have AI, you have sort of technological maturity across the board. If you have research being done by superintelligences, you're going to like very quickly do 40,000 years worth of human research. And so you then enter this very different kind of post-human world where you need to sort of, but I think that there are these interesting philosophical questions one could ask about that, but to some extent we don't need to worry ourselves too much about that. I think that if we get this chunk right, then what would constitute success here is that we end up on a path where people will be in a good position to then start to address these longer term. Like if we got through this critical transition intact, wise and in control of our destiny, then we can sort of have a long time available to figure out how best to use them. But that if we get this wrong, then we might end up on a wrong track or go extinct or something like that. So these sets of challenges I think are very important, although they are long term. I think they spill over to the shorter term in that we can kind of see now that we need to be at a certain place here. We need to have solved the control problem in particular. We need to have some reasonably workable solution to these governance challenges to sort of avoid some disaster happening there. So I think that while we can largely bracket the ethical questions related to the deep future, we do need to, at least some of us, think about the long term and start working on that, whilst of course also paying attention to the short term issues related to the applications as we roll them out. Thank you very much.